Hi, this is Brian Kim. I want to share with you case number 177 in the best way to do cataract surgery series. This is a fairly soft lens. You're going to see very efficient lens disassembly with double chop and cross chop. You're going to also see some signs of zonulopathy throughout the case, and I use those signs to help me decide if I'm going to place a CTR. You're going to see CTR placement, and the way I do it is hook the leading eyelet. By doing it this way, I'm able to reduce torsional stress on the zonules, and of course with double chop and cross chop, this also reduces zonular stress because you don't have to spin the lens when you're disassembling the lens with these techniques. So I'm using a cotton tip to steady the eye and use a corneal marker, which will help me to center incisor-rhexis. Again, using the cotton tip to steady the eye and fixating it, and then I make my paracentesis incision first on the right side and then the left side, making sure I'm parallel to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine and then some intracameral epinephrine. And then this is some dispersive viscoelastic to coat the corneal endothelium and flatten the anterior capsule. And this is a triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove, tunnel through the cornea, tunnel, turn the eye toward me, and then I enter. I use a cannula to control the eye, so I'm able to control the length of the incision. This is the sharp tip Haldane-Perkar forceps. Puncture the center, pull down towards me, grab the right side of the tear. And the length of that tear is really intentional. I'm able to make the length of that tear to match the corneal mark that I made, which really dictates the diameter of the rhexis. Again, very well controlled rhexis technique due to these forceps. Finish off the rhexis, burp some viscoelastic out, and this is the Capsulorhexis hydrodissection technique. I place the cannula under the rhexis edge contra-incisionally, get a nice wave, decompress on the left side, pulsing some BSS along the anterior capsule edge on the left side, and you can see it's already spinning, and I do the same thing on the right side. Irrigating the surface of the eye, adjusting the sleeve, lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma, removing the surface epinuclear material, placing the chopper under the rhexis edge contra-incisionally, the ficcative vertically sub-incisionally, bringing the instruments together. It crushes the lens. Horizontally, you can see there's no torquing, there's no translational movement. Very well controlled, no trauma to the capsular bag. Placing the chopper around the right heminucleus, performing the cross-chop maneuver, grabbing that first quadrant with some vacuum, crushing the lens between the instruments, and emulsifying the lens pieces. Very efficient, very easy, no fuss way to disassemble the lens, especially in these softer lenses. So I'm going to show this again in half speed. See the pronation of the chopper, sliding it underneath the rhexis edge and then turning it vertically, turning the ficcative vertically sub-incisionally, bringing the instruments together. You can see how I'm turning that. Very subtle. There's no distortion. There's no forces on the zonules when I do that. I'm able to fracture the lens. Why? Because the fracture point is towards the center, and that's why there's no zonular stress. Placing the chopper around the right heminucleus, pulling it centrally toward the ficcative, it fractures the lens, and the ficcative acts like a chopping block as the chopper is brought towards the ficcative and crushes the lens against the ficcative. Using some vacuum to grab that first quadrant up, lifting it out of the bag, and getting around it with the chopper and crushing the lens completely in half, and then using high vacuum and ultrasonic energy. In this case, using some high vacuum only to remove the lens pieces. Again, using crushing forces to mash the piece at the tip, and then using high vacuum to remove the lens piece here. And so that's why people are skeptical and they think there's a lot of zonular stress. There's no zonular stress. I'm placing the instruments around the lens piece, crushing it between the instruments. All the forces are directed towards the center. They're not directed towards the zonules. And so this is a very controlled way and a very delicate way to fracture the lens with this technique. Placing the chopper around that second quadrant, pulling it centrally towards the phaco tip, fracturing the lens. Again, the phaco tip immobilizes the lens piece because it's on the other side, and it fractures the lens very efficiently here. Turning the lens a little bit, placing the chopper around the lens, and being able to separate the rest of that second quadrant from the rest of the lens, lifting it up with some vacuum. And then again, crushing the lens with the, that's the beauty of this technique. You don't have to go pedal to metal with these soft lenses. It's really unnecessary, and you're exposing the cornea to unnecessary trauma. In this way, you can be very confident you're not causing a lot of endothelial trauma, at least relative to traditional techniques where you're having to use a lot of vacuum and ultrasonic energy to disassemble the lens. You can see I'm just using mechanical forces, and the CDE is 0 throughout the entire case. I turn the second heminucleus in front of me, placing the chopper around the lens, pulling it centered toward the phaco tip. It fractures the lens in half. Do the same thing under the third quadrant. Again, this is another cross-chop maneuver, making sure I hook the peripheral lens. You saw I had to do it twice there. I didn't get it all the way around. And then I'm able to hook the lens, crush the lens in half, and then using some vacuum to lift the pieces up, and then crushing the lens between the instruments, and then emulsifying the lens piece. Lifting that last quadrant up out of the bag, crushing it between the instruments, mashing the lens pieces, and then again using high vacuum to remove the lens piece. Again, using crushing forces. And remember, when I'm using the crushing forces, I take my foot off. I'm not utilizing vacuum in those moments. And by doing it this way, it's much more controlled. You don't have to worry about accidentally grabbing something that you shouldn't be. And all that's left is this epinucleus. I'm placing the chopper deep when I do that maneuver. So I take the chopper out. You can see here there's some ballooning of the conge at the paracentesis incision, so I just use a chopper to pull the conge back. Place the cannula tip in, take the phaco tip out, and I go in with the INA handpiece. Start subincisionally removing the cortical material. And this is where I start to notice that there's some zonular issues, because you saw how efficient and gentle the lens disassembly was. And so I didn't really see any signs of zonular problems, but as I'm removing the cortex, I can see a lot of puckering of the posterior capsule. Even in the periphery, you can see there's some stria lines that run parallel to the limbus here. And when you see that, I'm worried about, long-term stability of the bag in these cases. Again, when I'm trying to polish the posterior capsule, there's a lot of puckering of the posterior capsule in polish mode. There's a lot of puckering of the posterior capsule during cortical removal. I switch to polish mode, polishing underneath the rhexis edge. And so really, for me, during cortical removal, you can see a lot of verification that the zonules are not healthy. When the cortex is being pulled, you can see there's kind of lack of resistance or relatively weaker resistance as you're pulling, because the zonules don't have as much counterforce of holding the capsular bag back. So when you're pulling on the cortex, the capsular bag is also collapsing as well. And then when you're polishing the posterior capsule, you can see a lot of stria. It puckers into the INA port. Of course, because of the polymer tip, it's no problem. It's really very safe. And so that's another reason why I don't mind polishing the posterior capsule. And also, by using the polymer tip, I gain a lot of information, because when I grab the posterior capsule and it gets that puckering, when the capsule material gets into the port, I know I'm not going to hurt the posterior capsule. I'm not going to rupture the posterior capsule because of the polymer tip. And I've never ruptured the polymer tip doing this particular step. And so I'm filling the eye with some cohesive viscoelastic to fill the capsular bag, and I have to make a decision. I've already decided I'm going to place a CTR. So I go to low mag, and you can see the CTR is on that platform, and you want to make sure it's flat when you're hooking the CTR, otherwise it won't go in. And you make sure it's outside of that little indentation, that inset, and I'm able to grab that eyelet, and then it's able to internalize into the barrel. Lifting the incision with a Sinskey hook, and you can see it's going to be delivered clockwise. Grabbing the leading eyelet with the Sinskey, and then I'm delivering the CTR. Again, by doing it this way, at least in the early stages, there's no contact of the CTR to the capsular bag, therefore no zonular stress. Of course, at the very end, I do have to disengage the eyelets so that they can go into the capsular bag. But again, minimal zonular stress with that technique. And then once I have the CTR in place, now I'm going to start sweeping and polishing. I figured if I did it before, sometimes you'll see quite a bit of movement of the capsular bag as I'm sweeping. Of course, you have to have some counterforce, right? So when you're sweeping, you depend upon the capsular bag not moving, so you can exert that friction and pressure and force to sweep all those lens epithelial cells out. But if the capsular bag moves, that's really not a stable situation. So the CTR is helpful in that situation. So go ahead and deliver the single piece acrylic lens into the capsular bag. And going in with irrigation off, activating irrigation, making sure the haptics are off the optic, tilting it and rotating it 90 degrees clockwise, removing all the viscoelastic from within the bag. And of course, the capsular bag is much bigger than the lens itself, and so you're able to do these maneuvers knowing that you're not causing any zonular stress or problems with this maneuver. Repositing the optic back in. Polishing underneath the rhexis edge now. Switching the visco mode, removing all the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, this is a fairly soft lens, but you can see how easily and elegantly and efficiently I'm able to perform double chop, cross chop mechanical fracturing, essentially using the instruments as a cheese wire. I'm able to efficiently disassemble the lens without having to utilize vacuum ultrasonic energy, no sculpting, no lollipopping of the lens, no utilization and dependency on vacuum and ultrasonic energy. I'm using mechanical forces essentially to cheese wire the lens, and then cross chop, I'm able to fracture the lens from various angles. During cortical removal, you saw some weakness of the zonules, puckering up of the capsule, but again, the polymer tip is really very safe in those situations. I'm able to use a Sinskey hook to grab that leading eyelet, and as I deliver the CTR into the bag, I'm able to collapse the CTR to some extent so that it doesn't spring open and cause zonular stress or traction as the CTR is being delivered. That's the problem with the manual placement. It's going to cause peripheral traction on the zonules as it's being delivered, torsional stress on the zonules when it's being delivered. By doing it this way, there's minimal zonular stress. The CTR goes in atraumatically, and in this case, you can see there's a very well-centered lens, very stable situation. And I know this because as I'm removing the viscoelastic, oftentimes when you have weak zonules, you can see the lens is wobbling. But after the CTR is placed, you can see during viscoelastic removal, the lens is stone cold stable. And that's why I put that CTR in. Ultimately though, if the lens does dislocate down the road, the benefit of having a CTR is you can lasso it with the Cortex suture and then scleral fixate the lens and not having to explant the lens. So CTR has multiple advantages in the zonulopathy situation. So I hope this was helpful to you, and I thank you for your attention.